All right, let's go ahead and get started. I do want to welcome you to part 3 of Unit 0. We're talking about dimensional analysis, and I want to go over a few things before we move on and talk a little bit about how we determine whether we're going to need 3 steps or just 2. The answer really lies on where we're starting with and where we're ending up with. If we look at this table right here, what we can see is that the basic unit is this one right here. So when I say a unit, I mean a unit of mass, or I mean a unit of length, or a unit of whatever it is that I'm measuring. So if the basic unit, if for example, if I'm measuring in mass, the basic unit for mass would be a gram. If I'm measuring in volume, it would be a liter. So these are the basic units, and we base everything on the basic unit. So for example, a decagram would be 10 times a gram, or 10 to the first power. A hectogram is 100 times a gram. A kilogram would be 1,000 times a gram. Let's go the other way. Let's take a liter as the basic unit. A deciliter would be 1/10 of a liter. A centiliter would be 1/100th of a liter. And a milliliter would be 1/1000th of a liter. So we base everything then on the unit. And so let's take a look at a couple of problems that require only that we go to the unit or from the unit. Let's take a look at this problem right here. So notice we've got grams here. Grams is a basic unit. It's the basic unit of mass. So we're going to start with 8,000. That's what they've given me. So I'm going to say 8,000, and I'm going to abbreviate grams with a GR this time. It could have been either a G or a GR. I'm going to do a GR this time. I'm going to put that number over 1. That holds the place and make sure that I don't get mixed up later on. Whatever unit's in the upper left is going to go in the lower right in the next division. So upper left, lower right, just like that. And whatever unit I'm looking for is going to go in the upper right. So upper left, lower right must match. What I'm looking for goes in the upper right, just like that. Now I'm going to ask myself, how many grams are there in a kilogram? There's 1,000 grams in a kilogram. Notice the 1,000 goes on bottom. If it goes on bottom, notice also grams and grams are going to cancel away. If it goes on bottom, I'll divide. If 1,000 had been on top, I would have multiplied, but it's on the bottom, so I'm going to divide. 8,000 divided by 1,000 is going to be simply 8. And the unit that I'm left with is the kilogram. So 8,000 grams then is equal to 8 kilograms. Really is that easy. That's called dimensional analysis. And remember, if I'm either going from the basic unit to something else or from something else to the basic unit, I only require this one step right here. This one step right here. And I will talk about what happens when it gets a little bit more complicated because I'm not going from the basic unit. So let's take another problem. Let's say I do this one right here. We have 789 millimeters, and I'm going to meters. So meters is a basic unit, so I know I'm going to only need to do the one step. So I'm going to say 789, and that's millimeters, just like that. I'll put that over 1, just like that, times whatever unit's in the upper left goes in the lower right. Automatic, every time. And the basic unit goes on top. So I'm going to ask myself, how many millimeters are there in a meter? There's 1,000 millimeters in 1 meter, just like that. So millimeters and millimeters are going to cancel away, leaving me on the upper right with only one unit. That's the meter, and that's what I'm looking for. So in this case, I'm going to say 789 divided by 1,000. Don't need a calculator for this. Just move the decimal. It's right here now. Move it over 3 places to the left because I'm divided by 1,000. 1, 2, 3, and I get this number, 0.789, and that's meters. And that's it. So 0.789, or 789 millimeters is 0.789 meters. And that's it. Let's do another one. Another one with a basic unit involved is this one right here. Right? Liter is the basic unit of volume. So I'm going to start with what I know. We have 40 milliliters over 1. times whatever units in the upper left goes in the lower right. So we'll put milliliters right there. And then on the upper right, I'm going to put the basic unit that I'm looking for. I'm looking for liters. So how many milliliters are there in a liter? There's 1,000 milliliters per liter. Now milliliters and milliliters are going to cancel away, and I'm going to be left with liters. So I'm going to divide by 1,000 since 1,000 is on the bottom. So we have 40 divided by 1,000. Again, just move the decimal place over 3 times to the left because I'm dividing by 1,000. 1, 2, and then I'm going to need another 0. So I'm going to say 0.040, and that's liters. So 0.040 liters, and that'll do it for me for this last one. 0.040 liters is the equivalent of 40 milliliters. And that'll do it for the two-step problems. There is one more two-step problem, but we'll get to that. Let's try another one that involves, those were one-step problems. Let's try another one that involves two steps. That would be this one right here. Notice we're going from kilometers to centimeters, right? From kilometers to centimeters. And because we're going from a non-unit, not meters, but kilometers, to a non-unit, not meters, but centimeters, it's going to require two steps. So what we're going to do is we're going to say 14.28 kilometers, and I'm going to put that number over 1 times. Now, because neither one of these is the unit, I'm going to have to go through the unit. Upper left is kilometers, so I'm going to convert to meters right here. How many meters are there in a kilometer? There's 1,000 meters in 1 kilometer. Now kilometers and kilometers are going to cancel away. I'm left with meters, but that's not what I'm looking for. I'm looking for centimeters, right? So I need another step. So I'm going to put meters on the bottom and centimeters right there. Then there's 100 centimeters in 1 meter. So now meters and meters are going to cancel away, and I'm left with the unit that I'm looking for, which is centimeters, right? Now let's talk a little bit about how we handle these zeros. Folks, the best way to do this is just write the number that you have on top, which is 14.28, just like that, times 10 to the what? All you have to do is count up zeros. 1, 2, 3, 4, 5. Just add those two, and that's our answer, times 10 to the 5th. Now let's just say you want it in scientific notation. Scientific notation requires that you have one and only one number to the left of the decimal. So I'm going to move the decimal place over one place to the left, making it 1.428. But you can't move the decimal place one place to the left just because you feel like it. You have to compensate by, if you made this number 10 times smaller, 14.28 turns to 1.428, you made it 10 times smaller, so you have to make this part of the number 10 times bigger. So you have to say times 10 to the 6th, just like that, and that'll be my final answer. Okay, so that'll do it for that first one. It'll be 1.428 times 10 to the 6th centimeters. All right? All right, let's do one more two-step problem where we don't go through we have to go through the unit because we're not starting with a unit or ending with a unit. Let's do this last one right here. So here we've got 0.800, and that's decagrams. All right? Decagrams, just like that. I'll put that over 1, and then I'm going to multiply that by, now again, decagram is not a unit, milligram is not the basic unit, neither one of the basic units, so I have to go through the basic unit. Decagrams on the upper left, decagrams on the lower right, just like that. And I'm going to put grams right here. How many grams are there in a decagram? 10. 10 grams in a decagram. Okay, you can check your table if you're not sure of that. This and this are going to cancel away, and I'm going to be left with the unit of grams. But I'm not looking for grams. I'm looking for milligrams, so I have another step to go. So what I'm going to do is I'm going to put grams in the upper left, grams in the lower right, and what I'm looking for in the upper right, right? How many milligrams are there in a gram? 1,000. So I put 1,000 just like that, and a 1 right there. Grams and then grams cancel away, and here's what I'm going to be left with. I'm going to put what I've got, 0.800 times 10 to the what? Well, I've got 1 0 here and 1, 2, 3 zeros here, 1 plus 3, 4. Okay? Now, one little order of business, and that is this. This is not insignificant in scientific notation. To get into scientific notation, I'm going to move the decimal place over once to the right, just like that. And I get this number, 8.00 times 10 to the what? Well, I can't just move the decimal place to the right because I feel like it. I have to compensate. From going from 0.800 to 8.00, I made it 10 times bigger. So I have to make this 10 times smaller, so that becomes 10 to the third, and that unit was a milligram. And that'll do it for dimensional analysis. All right? Okay, so I hope that helps with dimensional analysis. And what I want to do now is I want to move on to another concept that's very important, and that's called experimental error or percent error. Okay? Now, when we talk about an experiment, there's going to be an error. All right? There's going to be some type of an error because of the fact that, well, there may be human error, right? That's possible. But there may also just simply be error due to the equipment that you're using. In either case, in either event, you have to be able to quantify that. So we have this formula. It's the percent error is equal to the accepted value. Some people write it like this. The value accepted minus the experimental value, and we'll talk about what that means in just a moment, divided by the value accepted times 100. That's the formula. So that's going to give us the percent error, how much error is in our experiment. So let's take a look at this problem. It says a student measures the length of a table to be 1.3 meters long. Now, calculate it says the accepted length of the table is 1.75 meters long. Calculate the percent error. So we've already said that percent error is equal to the value accepted. Well, they've told us the accepted value is 1.75 meters. So I'm going to say 1.75 minus the measured length, or the experimental length, is 1.3. So 1.3 right there. Divided by the accepted value again. So we're going to say 1.75. And then we're going to say times 100. So now we're going to need a calculator. So here we go. We're going to say 1.75 minus 1.3. I get 0.45. I'll divide that by 1.75 again. I get 0.257. And then I'm going to multiply that by 100. And I get this number, 25.7. So 25.7% is my error. Okay? And that'll do it. All right, on our next section, we're going to take a look at density. But I hope that clears up dimensional analysis and also percent error for you. We'll do a little bit more practice on the next one. Thanks. See you on the next one. Bye-bye.